40 grams of impure calcium carbonate reacts with a 200 centimeters cubed of a dilute sulfuric acid with a concentration of 1.5 mole per decimeter cubed. All the calcium carbonate and sulfuric acid react completely, leaving the impurities unreacted at the completion of the reaction.
Right. Thank you so much, Elsie. Well, that's not really the whole statement. Oh, there's actually a question before that. That's fine. So they say 40 grams of impure calcium carbonate reacts with 200 cubic centimeters of a dilute sulfuric acid with a concentration of 1.5 mole per cubic decimeter. All the calcium carbonate and sulfuric acid react completely, leaving the impurities unreacted at the completion of the reaction. And now they say calculate the percentage purity of calcium carbonate. Do you see that we are in acids and bases, and yet they're still asking us about the quantitative aspects? Because percentage purity is a quantitative aspect concept. But that's fine. In order for us to find the percentage purity, we actually need to calculate the mass of calcium carbonate that is present in this 40-gram impure sample. But they told us a very important thing. They said all the calcium carbonate in that impure sample has completely reacted with the sulfuric acid. That is very, very important. So let's go ahead and do that. Well, the first thing we realize is we are not really given much about calcium carbonate itself. So we have to use information about sulfuric acid in order to find the mass of this calcium carbonate. Okay? Well, both of them, they completely react with each other. So we don't have an excess reagent in this case. So equal quantities, correct ratios have actually been used in this case. Okay, fine. So let's get down to it. We know the volume for sulfuric acid. We also know the concentration, so we can find the number of moles. But of course, we need to begin with the original formula and say the concentration equals the number of moles divided by the volume. Then we know that the concentration is 1.5. We are looking for the number of moles, and the volume is simply how much? Well, it's given to us in cubic centimeters, which is an incorrect unit. So we divide by 1,000. So 200 divided by 1,000, that is 0.2. And now it's time for us to cross multiply. So when we cross multiply, we find that the number of moles of sulfuric acid will simply be 0.3 moles, like that. And well, since we can see that the mole ratio is 1:1, then he can either say the number of moles of calcium carbonate is equal to the number of moles of sulfuric acid. He can say this and tell us that this is 0.3 moles. But if you don't want to say this, then you'll have to tell us the ratio and say calcium carbonate and sulfuric acid, they react in a 1:1 ratio. which means that if you have 0.3 moles for sulfuric, you also have 0.3 for this calcium carbonate. Well, you could have said it in either way. So now we know the number of moles for calcium carbonate. It's now time for us to find the mass. Then we say the number of moles of calcium carbonate is equal to the mass divided by the molar mass. Okay, well, it's an uppercase M then. So we have 0.3 here. We are looking for the mass. But what is the molar mass? Well, calcium is 40, carbon is 12. We have 3 times oxygen. So we simply get 100. And if we cross multiply 100 times 0.3 will simply give us 30 grams like that. So now we know the mass of calcium carbonate in this impure sample. So it's very easy to find the percentage purity. So we can now say, well, the percentage purity is simply the mass of calcium carbonate divided by the mass of this entire sample, which is impure. So in this case, it's 40 grams. And then we times this by 100. And we find that the percentage purity will simply be 75%. So 75% of this entire sample consists of calcium carbonate. Well, they say to us to obtain the sulfuric acid solution of concentration 1.5 mole per cubic decimeters that reacted with the impure calcium carbonate. In order to obtain that, 10 centimeter cubed of a concentrated sulfuric acid solution. Yes, in order to obtain the sulfuric acid solution with a concentration of 1.5, that reacted with the impure calcium carbonate, 10 cubic centimeters of a concentrated sulfuric acid solution of a concentration of 9 mole per cubic decimeters was added to water. Do you see that? In order to end up with a concentration of 1.5, we had to take a concentration of 9 mole per cubic decimeter, which was originally in a volume of 10 cubic centimeters, and we added water. In other words, we diluted. Do you see that? We dealt with a dilution problem once. This is another dilution problem. Now they say calculate the volume of water that is required to dilute the concentration, the concentrated sulfuric acid solution to a concentration of 1.5 mole per cubic decimeters. So how much water was added in order to take the concentration from 9 to only 1.5? If you remember what we said with regards to a dilution, we said every time you are diluting something, the number of moles remains the same. So in other words, the number of moles before the dilution will be equal to the number of moles after the dilution. But now we are going to define the number of moles as the initial concentration times the initial volume, which is equal to the final concentration times the final volume. Originally, we had a concentration of 9 mole per cubic decimeter, and we took a volume of 10 cubic centimeters. For this formula, you don't need to convert the volume to cubic decimeters because the units will actually cancel out. Now we know that the final concentration is 1.5, and we are looking for the final volume, but it's the volume of what? Of the solution. It's not the volume of hydrochloric acid, it's the volume of the solution. And I told you that a solution is a solute as well as the solvent. So what we are looking for here is the volume of the solvent. We already know that in this final volume, there is already a 10 cubic centimeters. So here we need to know the volume of water, which is the solvent. Then if you go to your nice calculator and say 9 times 10 divided by 1.5, well, you simply get 60 cubic centimeters. This is the volume of the solution. Then you say, well, in order for me to get the volume of water, I simply need to subtract the volume of hydrochloric acid. And you find that 50 cubic centimeters of water was actually added in order to dilute this solution. Oh no. So 8.1, we are